got cut off for some reason. Distance from y to L, is this going to be the absolute value of y minus L? Distance from x to A is the absolute value of x minus A. So for this problem in particular, I'm just comparing when I am close to 0 by, well, that's what the absolute value of x tells me. Is my y value close to 0? That's what the absolute value of y tells me. So the question, when x is close enough, and by here I mean close enough to 0, will y be within, let's say, 1/2 of the limit point, which is, again, 0. So how do I know that y is in 1/2? I want to say that the absolute value of y will be less than 1/2. And can I pick an x that makes this formula true? Well, the reason I picked this simple function is that my y just equals x. So for y to have absolute value less than 1/2, all I need to say is that x has an absolute value less than 1/2. As long as x is this close to the coordinate 0, y will be within 1/2 of the limit. So there's my idea that the pendulum is swinging, and then over time the amount it diverges by shrinks. So at this point, right, from x within 1/2 of 0, I know that the y is not going to deviate by more than 1/2 from what the limit should be. Now this is just to say that it's only swinging within a value of 1/2. If it's eventually going to stop, it also needs to be within 1/4. So I can ask myself, when is the absolute value of y less than 1/4? Well, that's going to be, again, y is equal to x, so x had also better be equal to 1/4. Hooray! This is something I can solve for. As long as x is within this amount of A, y will be within this amount of the limit, L. So, if the limit is going to exist, we need to be able to solve this kind of inequality no matter how small the fraction is. So we need to solve the absolute value of y minus L less than epsilon, no matter how small epsilon is. That is the condition. The answer should look like y is within epsilon of the limit L so long as x is within delta of A. All right, that's a little bit terse. Let's break this idea down in the next video.